Hi, good afternoon. This is Mr. Mike here, going through and teaching you the chemistry paper 4 0620/42 February March 2025. Now, remember, I am also teaching, not just simply going through the papers. So take your time and enjoy the lesson and learn as much as you can. Now, using numbers only, state the percentage of oxygen in clean, dry air. So remember, just reminding you, nitrogen 78%, oxygen 21%. These are two main constituents. Then you've got carbon dioxide, you've got water vapor, but sometimes when they use the term dry air, then you would exclude water vapor, right? And of course you've got appreciable but small amounts of argon. But now the percentage of oxygen, so you'll write 21%, not just the number 21. Typical operating temperature in the harbor process, you have to memorize this. It's 450 degrees Celsius, right? Okay, let me erase that stuff there. Okay, next. Number of atoms in a diatomic molecule. We're looking at things like chlorine, hydrogen, oxygen. Of course, the number of atoms would be 2 atoms. So just mention 2, good enough. Now, maximum number of electrons in the second electron shell. Now, I keep harping on memorize your first 20 elements. If you do that, you recognize that the second shell can only hold a maximum of 8 electrons, right? Now, the number of hydrogen atoms in an alkane with 7 carbon atoms. So, alkane general formula is CnH2n plus 2. But with 7 carbon atoms, you just substitute C7 and you should get C16. But again, hydrogen atoms, so you just mention 16. The number of particles in 1 mole, again, this is the definition. Remember the Avogadro constant. So it's 6.02 times 10 to the power of 23. So note, these are things, the ones that I mark are all memory based, right? The others, I would expect every student to know this. Now, we go on to number 2. This question is about ionic compounds. State what is meant by the term ionic bond. Okay, so it's like for example, sodium chloride. It's sodium ions and chloride ions. So how do you get your full marks? You must state, okay, it is the strong, try and use the word strong electrostatic attraction, strong, I like to use the term strong electrostatic, it's not moving, so it's electrostatic attraction. That's 1 mark, but you must say between the oppositely charged particles. Okay, should be good enough. Now, again, I think it's looking a bit thick, so let's thin it a bit. Okay, great. Now, potassium sulfide is an ionic compound. Complete the dot and cross diagram. Now, again, first 20 elements at your fingertips. So you remember that potassium 19 is 2881 and sulfide is 286. Remember, this is 16. So what's going to happen? 2 potassiums are going to donate that electron to the 6th shell. So sulfur is 286. So both of them must have a third shell. So remember 2, that's for the first shell, 8, second shell. So we've got this shell. So we write nice circles. Of course, I can do it nicely because I've got this unfair advantage, my app. Okay, so 2, 8, 8 circles. Stick to circles because that's what the examiner uses for the inner shell, so we need to stick to that. But once it's donated, it's 1 electron, it'll become positive. So that's why we get the positives. So again, with its 8 electrons, right? With its 8 electrons. Now, meanwhile, let's look at sulfur. I'm going to do it in blue. So you got 2, 8, 6. So there's one more shell. Okay, so you draw the 6 of its electrons, but now 1, 2, 3, 4, 5, 6. And where does the third electron, that 8th electron, come from? It's coming from the 2 potassiums. So this will cause the sulfur will have to have a negative 2 charge. Okay, class? Okay, next. Ionic compounds form an ionic lattice. Figure 2.2 shows the part of the giant ionic lattice structure of sodium chloride. Complete the diagram. Of course, if it's minus, these must be pluses, which means that must be a minus. So this is a plus. Make sure your pluses are nice and neat. Alternating, class? That means a minus should be surrounded by pluses, and pluses must be surrounded by minus charge. Give the name given to any positive ion. It's a cation. And don't forget, if it were negative, then it'll be an anion, not a dog ion. A cation for positive and an anion for negative. Got that? Next, ionic compounds can be decomposed by the passage of an electric current using inert electrodes. Name this process. This is called, of course, electrolysis. But a word of warning here, class. If I were to ask you what is the definition of electrolysis, then you must say the passage of an electric current through an ionic substance in the molten or aqueous state. Okay, be careful when they ask for definition, especially for electrolysis. You must say molten or aqueous. Now, going on, write the ionic half equation for the reaction which takes place at the anode. Now, how do I handle this? Remember, what are we doing? We are looking at potassium bromide. So I'm going to write the thinking process. Okay, potassium bromide, agree? So it forms potassium ions and bromide ions. But at the anode, cathodes are negative, anode is positive. So what will happen? The bromide will head towards the positive ions and it will be discharged. So we write bromide loses an electron to form bromine. But we must know that bromine always exists as diatomic molecules. So you must have the 2 there, 2 there, 2 there. And remember, we must never see negative electrons. So we must transfer it to the right. Right? So this is no more. So I'm going to erase that. So that's important now, class. Of course, if you could write it straight away without thinking, even better. But when you're learning, this is how you would do it. Name the products and state the observations at the negative and positive electrodes with dilute aqueous potassium bromide. Again, first let me teach you about the thinking process. So I'm going to write it on the right hand side here. First, we've got potassium, bromine forming potassium and bromide, right? Then don't forget we've also got aqueous, which suggests that water is there. So we've got H plus and OH minus. So, and the key word dilute. That's going to happen. Product at the negative electrode. So positive ions would head towards it, but what would be discharged? H plus. Why? Because it is lower in the electrochemical series. So since H plus is chosen, ultimately what is the product? H plus will lead to hydrogen gas forming. Okay, but how about the observation? Gases or gas or bubbles of gas, bubbles of a, not just gas, try and use colorless gas given off. Okay, so bubbles of a colorless gas given off. Next, products at the positive electrode. Okay, positive electrode, what do we have? It's bromide or hydroxide, right? But dilute. The moment it's dilute, hydroxide is going to be chosen. And this is an empirical formula, remember, forming two waters and an oxygen. So what are the, notice plural. So you can say water and oxygen. Okay, observation, again, bubbles, because you cannot see water forming in water because it's aqueous. That's like you trying to urinate in a swimming pool. You won't be able to see your urine, something like that. Okay, so what can you see? But if you farted, you can see bubbles coming out, right? So bubbles of a, again, colorless gas given off. Are you clear, class? Great. Now we go on to question 3. Okay, now we start question number 3. Now the halogens are a group of elements in the periodic table. Chlorine is a member of this group. Okay, now you quickly look at the last page of your examination script. You will have a periodic table there. Okay, state the group number of the halogens. Of course, you can see VII there, that means it's 7. So you can either say group 7 or even 17 should be acceptable, but you say either one, not both. Now, how many halogens are there in this group? You can see fluorine, chlorine, bromine, iodine, astatine, and tennessine. So there are 6 in this group. Very clear on the periodic table. Suggest the identity of the halogen with a halogen which has the highest density. Class, remember, fluorine is a gas, chlorine is a gas, bromine is a liquid, iodine is a solid. So we can see the pattern that as it goes down the periodic table, it is getting more and more dense. So you would choose the last one on this group. So you would say tennessine, it's a new tennessine, tennessine, the 6th member in this group, is the most reactive. Reactivity increases as you go up. As you go up, reactivity increases. So your answer will be the topmost, which is your fluorine. State the name of the negative ions. These are called halides. Okay, halogens once reacted, like chlorine is a halogen, chloride is a halide. State how many occupied electron shells are there in bromine. So now you must check which period is it in, and you will see it is bromine is in period 4. So your answer is 4. Okay, or 4, either one. Now, name the noble gas which has the same electronic configuration as a bromide ion. So you look to the right, because bromine gains 1 electron, it'll go to the next element, and therefore it is krypton. Name, not write the symbol. So krypton, Krypton, right? Krypton, krypton. Name, not write the symbol. Now, aqueous chlorine reacts with aqueous iodide. Complete this. Now remember, this will be 2 iodide displacement. So in goes 2 chlorides. Right? Now, explain why this reaction is defined as a redox. I love oil rig. Oxidation is the loss. Reduction is the gain of electrons. So you must say chlorine has gained. Chlorine has gained electrons. No need to say 2 electrons. And iodide ion has lost electrons. Hence both oxidation and reduction occurs. Okay, so it's a redox. Give the color and state of iodine at room temperature and pressure. Color grayish black. Grayish, but once mentioned black. Actually, in my eyes, when I see iodine, it looks black. But the examiner says grayish black, so we have to say it's a solid, of course. Right? It's a solid. Now on to number 4. Carbonyl chloride is manufactured by reacting carbon monoxide with chlorine. Okay, recognize it's a gas with a gas and another gas. So of course you can only reach equilibrium in a closed system, right? And the conditions 200 degrees Celsius and 200 kilopascals. So what is meant by a closed system? Now class, the whole idea here is if you had gases which could escape, then it would never be able to reach equilibrium. Imagine if you could escape. So no, the idea is it can only, remember what's equilibrium? When the forward rate of the forward reaction is equal to the rate of the backward reaction, and concentrations of both reactants and products remain constant. But now they're asking for what is meant by the term closed system. So a system whereby both reactants and products cannot escape. Basically, it's a sealed system. Now, state what the symbol delta H represents. It's called an enthalpy. Delta is change, enthalpy change. State how the value of delta H shows that the forward reaction is exothermic. Remember, all statements here is always with respect to the forward reaction. So the forward reaction is exothermic. And how did we deduce that? The fact that it has a negative value, right? Deduce the value of delta H in the reverse direction. So it'll be positive 105 kilojoule per mole, right? Same magnitude, but now in the opposite direction, so it has to be positive. Now, complete the table. Okay, now for this kind of questions, I'm going to teach you some interesting ideas and how you can tackle this. Okay, class? So this is my table that I'm going to put on the right hand side for you to understand. Okay, because when you look at this equation, so I'm going to write the equation here. So we've got carbon monoxide plus chlorine, double arrow, reversible, COCl2, delta H in the forward reaction is negative. Okay, now when the temperature is increased, okay, so what will the system try to do? Will exactly try and do the opposite. It will try to decrease the temperature. Now, since the forward reaction releases heat, see, it's giving off heat. That's why it's negative. Heat is given off. And of course, will get hotter. So the system will try to cool it down. So it'll go in the opposite direction. So now you look at the direction on this side, it'll go in the opposite direction. And when this happens, the concentration of COCl2 will of course decrease, because we want the effect on the concentration. So this will cause it to decrease. Okay, take your time here. You may want to pause to make sense of it. I rather you understand than memorize. Okay, if we add some CO2, the system will try to remove. I will remove CO2. It does exactly the opposite. Remember Le Chatelier's principle? When a system is in equilibrium, any disturbance will cause the system to shift in the direction to remove the disturbance. So if I add CO2, how will the system respond? It will try to remove CO2. Now, how does it do that? It goes forward, right? It's trying to get rid of CO2, so it'll go forward. And if it goes forward, what's going to happen to COCl2? The concentration of COCl2 will increase, right? Okay, now let me get rid of all this other stuff for now before we tackle the next question. So COCl2, delta H is negative. Okay, next. If we add pressure, okay class, remember this is gas, this is gas, this is gas. So on the left we have a total of 2 moles of gas. Only gas for pressure. Here we'll have 1 mole of gas. On the right, 1 mole of gas. So when we increase the pressure, the system will try to decrease the pressure. So what will happen? It'll go forward, because now in the forward direction there's only 1 mole. So if it goes forward, it'll cause it to increase. Now, if a catalyst is added, of course, position of equilibrium will not be affected. No change. But don't forget, a catalyst, what will it do? It'll cause the equilibrium to reach in a much shorter time, because both the forward and backward directions will increase to the same extent. Therefore, the effect is no change. But both forward rates and backward rates will increase, but the equilibrium position will have no effect. Okay, so no change. Now, okay, so we now go on to F. The equation for the reaction can be represented by C triple bond O plus chlorine forming your product. Okay, now here you try and understand this idea, it will help you. Okay, remember this energy always goes in. This is bond breaking. Bond breaking is when energy must go into the system. Then what's going to happen is you will have bond forming. bond forming energy will always leave the system, right? Now this difference is your enthalpy, and of course since it's negative, this will go below the margin. So this is negative, right? And this value is negative 105, negative 105. Now I'm going to not mess around with the kilojoule per mole, just calculate the energy needed to break bonds. So we are looking at energy which is going into the system, so it'll be positive 1075 plus another 240, right? That should give me 1315 kilojoules per mole, right? Kilojoules, anyway, not per mole. Anyway, calculate the energy released. So bond forming, this is the red part, class. So let's call the energy which went into the system was positive 1315. The energy that was released from the system, I'm going to call that value X for now. And this is all equal to negative 105. Okay, this is all the red part. So what is X equal to? Will be negative 105. This moves across to the right hand side, and you'll get negative 1315, giving me negative 1420. Right? Okay, now we break it up into all the different bonds. You can see here, okay, you have 2 CCl plus the C double bond O. Okay, this is all equal to negative 1420. So what is the value of the two 2CLs? 2 CCl is 340. Okay, right? And remember, this also, it's negative, right? So because it's bond formation, so it's negative. So CCO is your subject now. It's negative 1420. So C double bond O, what do I get? Negative 1420. I bring this to the right, will be positive 680. Okay, so what's my final answer? Take your calculator, and what do you get? Negative 1420 plus 680, giving us equal negative 740. Okay, that is your final answer. Be careful, class. It's a bit messy here. I'll just transfer it down a bit so it doesn't. Yeah, that's your answer there. Even this. Let me bring it all to the right. Yeah. Okay. Got that, class? Again, pause, take your time. Look at that bond breaking, bond forming form. So this was trickier than usual. Now, complete the dot and cross diagram. Memorize your first 20 elements, and you'll recognize that chlorine has 8 electrons, 1 shared. So if you look at the structure, class, C double bond O, Cl, Cl, this is also has, because remember, each bond is a pair of electrons. So let's say that's the chlorine, this white chlorine, there's a C double bond O. So that's the 2 carbon atoms, electrons of carbon. So now chlorine's own one, I'm going to have circles now. 1, 2, 3, 4, 5, 6, 7. Again, 1, 2, 3, 4, 5, 6, 7. Oxygen has 6. So I'm doing it in color for you. Again, circle here. 1, 2, 3, 4, 5, 6. Okay. Draw nice and clearly, you should get that. Okay, making sense, class? Okay, we go on to the next one. Oh yeah, class, bond energies must always be positive. So actually this is the energy which is released. Therefore, sorry, this part, it's a bond energy, so it's positive 14740. Now, now let's go on. Now we start question 5. Manganese is an element with the atomic number 25 in the periodic table. Calcium is an element with atomic number 20. Now, the standard notation we have, X, is your proton number or atomic number is written below, and this is the proton plus neutron number known as your nucleon number, right? So, we've got for manganese 55 protons plus neutron, but they tell us clearly that manganese has an atomic number of 25. So this would be 25. Then protons plus neutron is 55. So all we have to do is 55 minus 25, and we get 30 for the number of neutrons. Now, since it is neutral, the proton number and the neutron number must be the same, right? Now, calcium 42, the number below is 20. So there are 20 protons, 42 minus 20, 22 neutrons. But be careful, it is positively charged, which means there is 2 electrons short. Since it's a positive charge, which means there's 2 protons above, 2 extra protons compared to the electrons. So the electron number would be less by 2. So less by 2 from 20 would give me 18, right? Now, manganese forms several oxides. The formula of these oxides are shown, suggests why manganese is expected. Of course, this is because it is a transition metal or element. Remember, all iron 2, iron 3, copper 2, copper 1, all of them are colored ions, typical of transition metals. State which other property of manganese is shown by formation. It has multiple oxidation states. Okay, state the formula of manganese 2 oxide. This means manganese with an oxidation state of 2, right? We always write it opposite, right? And then oxygen, we all know is 2. You simplify, giving you MnO. Now, M3O4 is found in an ore of manganese. Manganese metal can be extracted using aluminium as a reducing agent. Define the term reducing agent. So a reducing agent causes another substance to go through a reduction. So we start with oil rig. So reduction is the gain of electron. So the reducing agent causes another substance to gain electrons. Okay, so this substance, so what is the reducing agent? The reducing agent, or the reducing agent causes another substance to gain electrons. Itself will be oxidized. Do you follow this idea? Since it is causing another substance to gain, it is donating the electrons to the other substance. So it itself is going to lose. So therefore it will be oxidized. Now, complete the symbol equation by inserting the formula for the missing. Okay, now what you always do, class, this kind of things, work with elements all on its own last. So of course you're going to get aluminum oxide, right? That is your product. Okay, now you balance. Let's work with oxygen first. What is the common factor of 4 and 3? That will be 12. So I have to put 3 times 4, 12. Here 4 times 3. Now once you've got that, on your right hand side you have a total of 8 aluminiums. So you put your 8 aluminiums, and on your right hand side again 3 times 3, you end up with 9 manganeses, right? So work with these guys, elements which are all on its own last. Now always work with these guys last. The smaller the chemical, the easier it is to balance. Next, D. Manganese 4 oxide reacts with dilute hydrochloric as shown. Calculate the volume of chlorine gas in cm cube when excess MnO2 reacts with 50 cm cube of 0.2. Calculate. So of course first use N, the amount of HCl. We use the formula mV over 1000. What is our molarity? 0.2. What is my volume? 50 divided by 8000, right? So that should give us, that's 100, 0.01, correct? So then the number of moles of chlorine. Okay, looking at the ratio, if this, it's 4 is to chlorine 1, so you need to divide by 4, so it'll be 0.01 divided by 4, right? So that will be 0.0025, right? Right, and 0.2 times 50, must check that, divided by 1000, what do I get? Yeah, 0.01. Okay, so far calculate the volume of chlorine. Okay, now again, this one is already, we got the number of moles, so all we take is 0.0025 times the molar volume, which is 24 dm cube. But careful, it's in cm cube, so you must multiply this by another 1000. So 0.0025 times 24 times another 1000 to convert it to cm cubes, giving us 60 cm cubes, right? Describe a test for chlorine gas. Okay, how do you test for chlorine gas? You'd use blue litmus, or sorry, damp blue litmus paper. Observations, it'll be bleached white. Okay, next, explain in terms of collision theory why decreasing the temperature decreases the rate of reaction. Okay, decreasing the temperature. So when you decrease the temperature, what will happen? First you start with the particles will have less kinetic energy. You say the whole thing, class. I'm too lazy to write. You write. The particles will have less kinetic energies. Therefore, they will move slower, and the frequency of collision decreases. Therefore, rate of reaction, you say the full thing, decreases. But that's only 2 marks. The third mark, always my students are leaving this out. The third mark, where is it coming from? You must also say the percentage of reacting particles with activation energy decreases. Therefore, rate of reaction will also decrease. Okay, class? Okay, so we go on to the next one. Okay, now, number 6. The structural formula of 2 compounds, A and B, are shown. You can see one has 3 carbon system, one has 4 with a double bond. So they are both alkenes. Give 2 reasons why the structural formula of A and B show that they are members of the same homologous series. First thing, they have the same functional groups. Here the double bond, and of course they also have the same general formula, right? Why A and B are both hydrocarbons? Because they contain hydrogen and carbon, but don't forget, only. The examiner always underlines this only. So if you don't say that only, you lose your mark. Write the symbol equation for the combustion of A. Okay, so in total it's C3, you can count H6 plus oxygen, and you know combustion of hydrocarbons give you carbon dioxide and water. That gives you 1 mark. Now the balancing, 3 carbons on my left, so I put on my right the 3 carbons, then 6 hydrogens, another 3 here, giving me a total of 4 times 2, 6 plus 9, 6, right? 3 times 2 here, 6 oxygens plus another 3 oxygens, so a total of 9 oxygens. Not 90 there, class. 9 oxygens. So that was a 3 there. 3 carbon dioxides, right? 9. So I need to have a 9 over 2. But many people are not too comfortable with fractions, and I also think that examiners don't like fractions, so we better multiply throughout by a 2. So that this becomes 2, and this becomes 9, and this becomes a 6, right? And this becomes another 6, right? You got that? So get rid of all the stuff, but we don't want fractions anymore, so that's why I have to get rid of the fraction. So let me get it a bit neater. Yeah, that's 9. Okay, deduce the empirical formula for A, simplest, remember C3H6, simplest whole number ratio, so it's CH2, right? Name the compound B. It's a butene, but the double bond is at the second carbon, so it's but2ene. A structural isomer of B is a member of the same homologous series. Draw that. So you can draw but1ene. That would be the easiest, though there are others also. So don't forget, each carbon must have 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. place in your hydrogens, and this would be but 1ene. That's F. Now G. Compound B reacts with aqueous bromine at room temperature to form product C. The equation state why this is an addition reaction. So when only one product is formed, so it adds on to become only one product. Describe the color change. It's orange to colorless. When the orange bromine will be decolorized. Yeah? Name the product. Now it is on the second and the third carbon. Right in blue, second and the third carbon. So the bromine goes there. So what's the name? 2,3 dibromo butane. There's no double bond, right? Under certain conditions, 1 mole of B reacts with oxygen to form 2 moles of a dicarboxylic acid. 1 mole of B forms 2 moles. Draw the displayed formula. So obviously, class, it must have attacked the center to create 2 identical products. Follow? So what's the carboxylic acid? It'll be a 2 carbon system. So C double bond O, OH. It's the hydrogens all there. Count, carbon always has 4 bonds. Hydrogen 1, oxygen 2. Name the carboxylic acid. Ethanoic acid. Complete the symbol equation for this reaction. So complete the symbol equation for this reaction. So here what you do is you first count how many carbons was there here. So if you look at the total amount of carbon, C4H8. Now ethanoic acid is CH3 COOH. So what do I have? A total of 2 carbons, right? 2 carbons. How many hydrogens? 3 plus 1, 4 hydrogens, and another 2 oxygens. And remember, we deduced that it was 2 of them, so you have 2 C2s, 8, a total of 8 hydrogens. And look at your oxygens now. How many do I have with this? In total, there'll be 4 oxygens. So we must add another 2 oxygen molecules to balance your oxygens. Is that making sense, class? Again, because I first started with our ethanoic acid. Again, I do it for you again. Remember what is ethanoic acid? CH3COOH, giving me a total of 2 carbons, 4 hydrogens, and 2 oxygens. Now we knew there was 2, so you count that all. That gives me a total of 4 carbons, 8 hydrogens, and 4 oxygens. So there was no oxygen, so that's why I needed another 4 oxygens, and I end up with this. Okay, I hope you understood as much as you could. Thanks for listening, and hope to hear from you and enjoy your studying, and all the best for those who are sitting for the May-June 2025. I wish you the best. Take care and have a pleasant weekend. Bye.